Okay. So today in organic chemistry, we are doing Sn reactions. Okay, Sn1 and Sn2. So first we are doing is unimolecular nucleophilic substitution reaction or Sn1. Okay, why it is called unimolecular? It is called as unimolecular because the rate of reaction, okay, it only depends on concentration of alkyl halides. Okay, that's why it is unimolecular. It does not depend on the concentration of nucleophile. So it doesn't matter how much nucleophile you add, the rate of reaction will be not affected. I hope it is clear to everyone. Students who are attending online, kindly confirm why it is unimolecular.
Yes, sir.
Okay. Now,
So wait, could you repeat the statement again? Why is it
statement is the
unimolecular?
rate of reaction is directly proportional to the concentration of alkyl halide. It only depends on the concentration of alkyl halide. It doesn't depend on concentration of nucleophile. Okay. So write a note. It does not. It does not depends on rate of reaction. Does not depends on concentration of nucleophile. I hope it is clear. That's why it is depending on only on alkyl halide. It's unimolecular. Everyone's clear about it. Now, what is nucleophilic substitution? Nucleophile substitutes the another nucleophile. One nucleophile will replace the another one. Is it clear? Got it, no? What is a nucleophile? Nucleophile is a electron rich species, and because it is rich, it can donate. You will never you will never hear that poor people donates. It's the rich who will donate, right? Got it, no? Understood. Now, so guys, understand similarly, electron rich can donate and electron poor, which is an electrophile, can accept. Is it clear, no? Now, so moving further, now we will see some important points about, some more points about the nucleophilic substitution reaction. So first point is, remember, it has a carb-cation intermediate. See, whenever you study organic chemistry, any reaction, try to understand what is the intermediate in that. Because if you know the intermediate, your 90% job will be done. As we know, intermediates are very short-lived substance species, right? But they are the one who decides what will be the product, correct? So as we know, the intermediate is a carb cation, right? It has a carb cation which we represent it as C plus. So it has a carb cation intermediate. So my dear students, take a note of this, and we know if there is a carb cation intermediate, what will be the stability? So rate of reaction is directly proportional to the stability of this intermediate. And it also means what is the stability of carb cation? The stability of carb cation, what is it? It is 3 degree, highest, then yeah, and the least is 1 degree. I hope it is clear. Now, can anyone explain me why 3 degree is more stable? Hmm? That is what you'll tell because of the structure. But what is there in the structure? Huh? मतलब कुछ भी कहीं भी स्टेरिक सेंटेंस उठा के और मार दो राइट and let me tell you, when I was correcting the paper, you know what I came across in especially the questions from lanthanide actinoids. When people are not knowing anything, they put lanthanide contraction, they put actinide contraction. Guys, please understand, it's not only that, okay? Now you need to put some logic in it, okay?
Suppose like the electron density on the graph increases, therefore it's more stable and
Plus means plus means less. So density ज़्यादा कहाँ से होगा? How it will be more? Good, good things, John. You have to answer anything. Why 3-degree carpetan is more stable? Okay. Okay. Online, Mohit, you want to say something? Arav, Vishal, Manas, Tanvi, Aditi, Daman. Yes, go ahead. Now you got it. Yes. You should say what you said.
That's what I meant. That's exactly what I meant.
See, what you mean or what is in your belly,
Right.
you don't get marks for that.
Saying
Okay. See, Manas also
Sir,
have to say something. Yes, Manas.
is it Plasai effect?
Ah, now Manas is also recalling. Yes, so what you said, Anushka, so much, it is called, sorry, Anushka, my bad. So what it is, it's a plus I inductive effect, right? Let me explain you that. 11th को सब खा पी के डकार मार दिए, right? You people have, guys, pay attention now. It's okay, it's just another K added, right? Guys, now please pay attention. What I'm trying to tell that you people have eaten grade 11 very nicely. Now, let's go into concept. The concept says first draw the structure. So let me show you a 3-degree carbocation. See, this is what we are going to discuss for the entrance classes. Okay. Now, understand here, we will be focusing mainly on 11th. But doesn't mean that when we are rushing for the 11th, you people forget 12th because the board is over, right? Don't do that. Now, so tell me now, what degree is this one? The second one. Yes, the carb-cation carbon is connected with two carbons, so it's 2 degree. Here, the carb-cation carbon is connected with second now. And one more I'll draw. That's the methyl carb-cation. It is also 1 degree. Yes, Daman.
So the 3-degree one will be
Oh,
more stable
Manas, yes.
because the CH3 is an electron donating group, and since we have three,
Thank God everything working properly. Okay. Now, see, Manas, see here. Let me explain that. Guys, all of you pay attention here. What I'm trying to tell, this carbon is a poor fellow, right? Can you all see that? There is a loss. So you need, loss means you need someone who can donate the electrons, right? Remember, alkyl groups are very good electron donors because they show plus I effect. Plus I means when electron goes to the carbon. You know inductive effect, right? The shifting of sigma electrons, single bonded electrons. Resonance is shifting of pi electron. Inductive effect is shifting of sigma electron. So towards the more electronegative atom, right? So here these alkyl groups are electron donating group. Mark it because when I teach you acidic and basic nature, again this concept will come up. Is it clear? You cannot do 12th without 11th, okay? But it doesn't mean now you go in depression. Oh my God, you're doing 11. I'm here, I'm telling you, okay? Is it clear? No? So understand. So how many guys, how many groups are there? How many alkyl groups are there? I told you, alkyl groups are plus I groups, right? They donate electron, they deposit electron. They are electron donating groups. Or in some textbook, they have written as plus, they are also called as electron releasing groups. ERG or so how many groups are there? Can you all check? Three. It has got three supports. How many support it has? Two plus I groups. How many plus I groups are there? So plus I groups are three here. How many are here? Two. How many it has? One. But how many this one has? None. Hydrogen is neither plus I nor minus I. It means hydrogen is zero. Means nothing is happening as it is. Okay, Parinit? So there is zero. So you can understand who will be more stable, who has more support, who has more donors. If you have a positive charge, tell me. Of course, that is why the stability order is like this. The 3 degree is the most stable, then 2 degree, then 1 degree, and least is the methyl 1 degree. That's the methyl group, right? The methyl carpetine, that also is 1 degree, okay? I hope it's clear. Now, one more thing I'll tell you. Whenever there is a carpetine intermediate in any reaction, there is always a chance of rearrangement, shifting. But in 12th, you don't have that, but for the entrance, you will have that. So when we will do the entrance part, then I'll tell you all this. For now, just carry on with this. Online, anyone has a doubt till here?
No, sir.
In board exam questions, rearrangement. Okay, maybe in the end, I'll tell you that. It's not a big issue, okay? I don't think so, it's there, rarely, but still, in the end, I'll tell you that. Don't worry about it. For now, just leave it, okay? All right. So nobody has a doubt, but this is only one reason. Inductive effect, plus I effect, plus I means electron donating group. They increase electron density. So this is one of the reason. But there is one more reason which is stronger than plus I. However, they both are supporting each other, okay? So the another reason is hyperconjugation. Hyperconjugation. All of you remember this is the reason one. This is the first reason. This is the second reason. Hyperconjugation. Now, what is hyperconjugation? Hyperconjugation is also known as no bond resonance, aka it's called as no bond resonance. Guys, got it? No? No bond resonance. What this says, it says if you have more alpha hydrogen, it says if you have more alpha hydrogen, then there will be more no bond resonance structure. It will have more bond resonance. And if more no bond resonance structure will be there, then there will be high stability. What will be high, guys? There will be a very, very high stability. All right. Please understand that. So you might want to mark this thing. Okay, so I'll just do it for you. This is super important. You should mark it, okay? It's very, very important, okay? Now let's see the structures again, which I have shown here. Now, guys, tell me the carbon which is connected with a carb cation carbon are called alpha carbons, and alpha carbon hydrogens are called as alpha hydrogen. So in that way, tell me how many alpha hydrogens do you see here? 9 alpha hydrogens. How many alpha? 6 alpha hydrogens. How many are there? 3 alpha hydrogen. Without alpha carbon, there is no alpha hydrogen. Got it? Because this doesn't have a carbon, alpha carbon, so the hydrogen will be not considered as alpha. The rule is hydrogen is considered as alpha only when, oh my god, what is that? Bumblebee. Okay. So guys, got it? No? Leave it, leave it. It will be attracted to the light. Understood, understood everyone. So how many alpha hydrogens are there? There is no alpha carbon, so zero alpha hydrogen. So this region also supports who have the highest alpha hydrogen? 3 degree carbocation. It means that by plus I or by hyperconjugation, your answer is 3 degree is the most stable carbocation. Same to same order is followed in free radicals also. Free radical also have one less electron, right? They are odd electron species. Same to same rule is there. 3 degree free radical is the most stable, then 2 degree, then 1 degree, and then the methyl. I hope it's clear to everyone. Online, please confirm, am I still connected? Can you all hear me? Can you all see the board?
Yeah.
Yes, sir.
Yes, sir.
Okay. Thank
Yes,
God
sir.
today backup is working very nicely. Okay. So yes, very good question. What if, sir, if alkyl groups, I'll change it here. So remember, bigger the alkyl group, bigger is the plus I effect. If you want, you can take a note. Huh? Hmm. Okay, are you saying that, let's say,
It's only
you got it right?
I didn't get it.
Just remember, if more is the plus I group, more will be the effect. Simple. More plus I, more effect. And simple, if you're confused with plus I, check for hyperconjugation. Your doubt will be clear. All right, because hyperconjugation is mostly, hyperconjugation is not clear.
No, I will. Last time.
Remember your Stetzev rule. Have you heard of Stetzev rule?
Yes.
Ha. So that Stetzev rule is also based on hyperconjugation only.
Like more analyze less.
Yes, it is based on Stetzev rule, is based on hyperconjugation only. Anyways, leave it. Guys, please finish writing this if you want to. One more thing, you can get the recording. Hey, should I talk now? Can I talk? Okay, guys, I just realized looking at the diagram. What is the diagram is about?
I didn't get my books today.
No, okay, but from that angle, that is physics, right?
Yeah.
But when I saw from this side, that angle, I thought it's isomerism, okay, optical isomerism. So it reminded me one thing. There is a bit more of isomerism. I am still have to tell. Yes, I still have to tell you. Yes, there's a bit more I have to tell you.
Do that question also.
And one topic is also pending, that metal carbonyl wala, right? That we'll do in chemical kinetics class. Okay, let's not mix up too many things. Okay, but since we started organic right now, so let's continue with that. Okay, then once I finish SN1, SN2, in the last I might tell you the isomerism. Okay, or maybe tomorrow only. Okay, is it clear? So let's not complicate. So it's all your job to remind me that, sir, coordination small part is still pending. Okay. Okay. Now, guys, let's continue now. So, we saw one important point. It has a carpetine intermediate. Now, let's write another point about it, that in this SN1 reaction, we use polar protic solvent. What do we use? Polar protic solvent. What is the solvent we use? Polar protic. Very soon I am going to tell you in the mechanism what do you mean by polar. I mean polar, you all know. What is protic? But take some examples, that is very important here. Anyone tell me the example? The best example is H2O, then alcohol. After that, one more is there, acetic acid, CH3COOH. So, dear students, these are your examples of polar protic solvent that we use in SN1 reaction. Okay, leave it. Okay, guys, understood? Please take a note of it. Okay. Online students, let me know if I'm hindering the board too much. I don't want to cause the steric hindrance. Okay. So do let me know. Okay. See, Dhruv.
Sir,
Yeah. There is a place where
sir,
you
could you
use steric
explain
hindrance.
what polar protic does again? So,
I have not explained what polar protic does. I'm waiting for the mechanism to start. There only I'll tell you the role. Okay. Now,
okay.
guys, let's write down more points about SN1 reaction. In SN1, huh? Yes, SN1 reaction is a two-step reaction. Write it down. It is a two-step reaction. It is a two-step reaction where what happens in the first step, there is a formation of carbocation. First you form, there is a formation of carbocation in step number one. Step number two, attack of. Then there is an attack of nucleophile. Yeah. After that, you need to write some more points about SN1 reaction, that it gives it gives retention and inversion products. Soon I'll tell you in mechanism. All of these, first of all, write down the points about SN1 should know. Okay. Moreover, you should write about the reaction is exothermic or endothermic. Tell me. Reaction is exothermic. Dear students, it is exothermic means the heat will be reduced, released. Acha, you said produced. I heard reduced. Okay. So guys, copy all these points. Also, you should write it down. The rate of reaction depends on one more thing. Rate of reaction is directly proportional to the leaving group. So, guys, rate of reaction depends on the good leaving group. Now, the options we have here is chlorine, bromine, and iodine. So, who is the best living group? Iodine is the best living group. Please remember this. This is your order for the reactivity, okay? Please remember this. Now, the reason, what is the reason behind it? So, remember longer, due to the large size of iodine, it has a longer bond and long bond are easy to break. That is why iodine leaves early. So, iodine is the best leaving group.
Sir,
Yes, tell me.
sir, can you explain retention and inversion point?
Retention inversion point you will soon understand in the mechanism, and polar protic nature also you will understand very soon. First write down the points, okay?
Okay, sir.
So guys, why iodine is the best living group? So write down due to large size, due to due to large size, due to large size of iodine, bond length is long, is long, and bond dissociation energy, bond dissociation energy is less. So that is why it is the best living group. All right. Online, is everyone clear about this? Guys, make sure that you will get the recording for this in the YouTube, but you will not get the notes, however, sharing the Miro board link. So notes you will not get it, okay? So for the notes, you might have to watch it all over again. So it's better you write the notes. If you have it already, it's fine. But if you come across some new points, then definitely take a note of it. All right. So let me know when it rains too much. I'll close it off. Okay. Hmm? All right. So guys, write it down. One more thing, guys. Remember, because it is exothermic, how many people remember the Lee Chatelier's principle in equilibrium? When you disturb the equilibrium by adding heat, adding pressure, removing the concentration of reactant or removing the, matlab, anyhow, somehow, if you disturb the reaction, okay, it will try to undo the effect, negate the effect of the made changes made, right? So how it can undo the effect? Either by shifting backward or by shifting forward. Somehow, how it can undo the effect. Is it clear? to negate the cancel out the effect. It means equilibrium wants to again achieve the equilibrium just by cancelling out the changes made, either by shifting towards the left or shifting towards the right, means forward or backward. I hope it is clear. That is Le Chatelier's principle. So, because this reaction is exothermic, in the Le Chatelier's principle you have studied, for the exothermic reaction, the reaction shifts I mean not backward. I mean those reactions are more favored at lower temperature. That's how it can be, you know, canceling the effects. Is it clear? So write it down. That is why SN1 reaction, SN1 is favored. That is why SN1 reaction is favored at low temperature. It is favored at low temperature. Today today also and yesterday also, my mom was very angry on me. I'll tell you a reason, the fun fact. So she was asking me that today is a very auspicious day, right? So did you give holiday to your kids, right, students? And I said no. Rather than that, I put the extra class. So she was very angry. But later on, I told, right now, the biggest worship what we have to whatever God we pray is the exam, our study, because that is going to make our life, our career, right? So we will also celebrate all the festivals when you all come up with the good marks. I promise you that we are going to celebrate right here only. Okay? Is it clear? Ha ha. We'll go to Goa also. We will go to Goa also. Okay? Not just you, everyone has to go, right? I don't want anyone to miss out the van, right? We'll make some plans, okay? We'll go somewhere, okay? For sure. We'll call it as success trip. Huh? Yeah. So we will call it as like success trip. All right. So guys, please write it down. Because it is exothermic, it will be favored at low temperature. Remember, I gave you one background, okay? Remember, SN reaction and elimination reaction, they are very competitive to each other. Okay, it's like India and Pakistan. They are very competitive to each other. Okay, I mean Pakistan now is a bad example. India and China is a better one now. Okay, we are much better now. So India and China. Okay, so what I'm trying to tell is SN reaction and elimination, they both fight with each other. Okay, and whichever is able to make its first, whatever attacks first. Let's say in elimination reaction, if the electrophile attacks first, it will be declared as elimination, right? And if the nucleophile attacks first, it is declared as nucleophilic. So remember, you never get a pure product of SN reaction or elimination. It's all mixed. But who forms the major is decided by what attacks first. So in order to ensure the SN reaction wins, it forms the major, right? It dominates. You have to keep it at low temperature. If the temperature, if you keep it above 20-30 degree, not even 30, if you increase it by 20 to 23 degrees Celsius above, then elimination product you will see, not the nucleophilic substitution product. That is why it is a very, very important point. Okay, in NCRT also it's given as a column. One sec. One disaster has happened. It's not connected. My bad.
So your video was lagging in between.
It was lagging because it was not connected to the charge, but I guess it's fine now. Is it fine now? Just wait for 2 minutes, okay? It will be okay. Guys, can you all see whatever is written here in the board? Can everyone see it?
Yes.
No,
Yes,
obviously
sir.
you can see it. I'm asking with online students. Aditi,
Yes.
did you catch up with whatever I have explained
Yes,
till
sir.
now?
Yeah.
Okay, okay. Chalo, the collapse has stopped. Okay, so guys, let's write some more points. Now, let's see the reaction. So, guys, now tell me, in order to learn the mechanism, give the headline mechanism. Guys, all of you write it down the mechanism. Now, in order to learn the mechanism, tell me which carb cation should I take? I mean, which alkyl halide should we take? 1 degree alkyl halide, 2 degree, or 3 degree? Yes, we will take 3 degree alkyl halide, right? So take a note of it. We will take 3 degree alkyl halide, okay? CH3, 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 and let's take Br. Or let's take the best living group, guys. So we'll take iodine. Guys, let's take iodine here, okay? Okay? Now tell me, what was the solvent we were using? What was the solvent we were using, guys? Huh? Yes, we were using polar protic solvent. I hope it's clear to everyone. So we will add the H2O. Can I write H2O like this? HOH. Tell me. So remember, it is a solvent also, and this H2O only will give you the nucleophile also. Guys, got it? No, because H2O is in higher abundance, right? So it is working as a solvent also, and it is working as a reactant also. I hope it's clear to you all. Now see what is gonna happen. First of all, let me tell you what is the nature of H2O? Polar protic. One more thing in the mechanism, this is called step one, formation of carcation. You already know that, right? Step number one. So polar, first of all, focus on the word polar. What do you mean by polar? Polar means ability to break the bond. You know, and water has a very high dielectric constant value, 81. It means it can break this bond up to how many times? 81 times. Is it clear? That's the polar. So it means this bond will break. It will cleave, right? Now tell me, when this bond breaks, isn't it the positive charge will come here? Because iodine being more electronegative, it will take up the electron, right? Okay, I minus will be removed. So we got the 3 degree carpetan. I hope it's clear to everyone. Online, polar nature, breaking of the bond, right? CX bond will break. CX bond is breaking, right? Because of the polar nature, okay? Is it clear? Now, coming to the next part now, understand, now tell me what we got. So let's write down the structure here. Yeah, we got 3 degree carpetan, right? See, the more you write, more you remember. 3 degree carpetan. Now tell me if this 3 degree carpetan, tell me what is how many sigma bonds are there? All of you tell me how many sigma bonds are there? One, two, three. There is three sigma bonds. I hope it is clear. Why the power is cut is happening so much today? Okay. So guys, 3 degree three sigma bonds are there, right? So three sigma bonds means what is the nature? sp2. It is planar. I hope it is clear to everyone. This has a planar nature, right? sp2, correct? Yes or no? Yes. So what do you mean by planar? Guys, what do you mean by planar nature? Planar means on the surface, on your plate, on your hand, right? On your palm. So because it has a planar nature, hey, pay attention. Because of its planar nature, the attack can happen from the top or from the bottom. That only we are explaining in the sense of front and rear. It can have attack from both the sides, front also and rear also. So write it down due to the planar nature. Write a point here. So guys, due to the planar nature of sp2 hybridized carpetan, due to the planar nature of carpetan, nucleophile nucleophile can attack nucleophile can attack from front and rear position. I hope it is clear. Front and rear positions. Is it clear? Now, the question arises here, sir, how do we know who is front and who is rear? So remember, the front and rear positions are decided by the position of the old nucleophile. It means, who was the old nucleophile? This iodine. So when this iodine is here, and at the same position, if you have a new nucleophile, then it is called the attack happened from the front. But if from the position of iodine, if the new nucleophile came exactly opposite, then it's called the attack happened from rear. Is it clear? Online, is everyone clear? How do we know the front and rear?
Yes, sir.
Yes, sir.
Front means, so remember, the front gives retention, means it's retained. The structure is retained. So that is why it's called retention. Okay. Write it down. When attack happened on the front, it's called retention. And when attack happens from rear, it's called inversion. One more thing, remember, guys, when retention plus inversion, when they both are in 50-50, then this substance is called, it's called as, it is a racemic mixture, and the phenomena is called as racemization. It's called racemic mixture. Guys, please take a note of this. Okay. So all of you have understood, right? How do we decide front and rear? Old nucleophile position decides who is front and who is rear. So when the old nucleophile position, the new nucleophile came at the same place, that means it is retention. If it came opposite, then it's called inversion. Okay. So guys, now we will go to the, I think we did step number one, formation of carpetine, right? Now see, let me tell you one more thing. So guys, understand, iodine is a very strong halogen, right? Correct? It's, so understand, when the water, so what is the nucleophile will come out from the water? So it will be a OH minus ion. You can see that this is your nucleophile ready. Is it clear? So water is acting as a solvent also, and water is only forming a nucleophile. Got it now? So understand now, the problem here is this iodine, which is a halogen which is removed from here, it will have a higher chances of rebound. Guys, getting it right? There will be a higher chances of rebound. Understood? So in, it means in simple words, when the breakup happens, there is a chances of a rebound. To ensure the rebound should not happen, this water, what it will do, let me show you. So what is removed from here? Tell me. I minus. So guys, please see here. This I minus will be captured by the water. So water only caused the breakup. Now iodine will be captured by the water. Okay. How it will be captured? Let me show you. So this is the structure of water. Tell me, all of you agree to it or not? H2O. Let me show you the H2O. Let me draw the H2O properly. So guys, please see here. This is the oxygen here, oxygen here, oxygen here, oxygen here, and these are the hydrogens. Can you all see this? See how water is capturing it. The water will capture it, okay, with I minus this H plus, right? Guys, getting it? They will capture it like this. This is how they'll hold on to it, iodine, right? Guys, getting it? This is how the, huh? So this is how the iodine is captured. Is it clear? Online, is everyone getting it?
Yes,
So
sir.
this nature is called protic. Breaking of the bond was polar and capturing the nucleophile so it should not rebound is called protic nature. Is it clear? Polar protic, right? So now what is going to happen? Now the what basically water is acting as a real villain here, right? First, it has done the breakup. Also, it has captured it. So there should be no rebound. Okay? Understood, everyone? So now, let's attack it finally. So step number 2, attack of nucleophile. So guys, let's see the step number 2. So in step number 2, let's draw the carbocation. Our carbocation is here. Now finally, this nucleophile is ready to attack. Dear students, please see this. There will be there will be attack. Positive, negative, electron poor, electron rich. Perfect match. Understood, right? So you will have two answers. Okay. First, where was the halogen was present? It was present here, right? So if the OH comes at the same position, then what do you get? Tertiary butyl alcohol. Am I right, guys? Tertiary butyl alcohol, 3-degree alcohol. This is your, which answer is this? Say, this OH has come at the same position where the old nucleophile was. That is why we call it as retention. All right. And now, if you see here, if the OH comes on that side, just the opposite, guys. This is also a tertiary butyl alcohol only, but look at that OH, it has come just opposite. The attack happened from the reverse. So, front and rear, right? So remember that forms inversion. And when both are in the equal amount, we call it as, what do we call it as? Racemic mixture. The phenomena is called racemization. Okay. All right now. So remember to check for Sn1, QC, remember 321, carbocation, and also the leaving group and the low temperature. I hope it's clear. Keep all these in mind, okay? And also polar protic solvent. Correct? Understood now? Guys, now let's go to Sn2. So when I'll talk about Sn2, in your mind, parallelly, you should think about how it is different from Sn1, okay? It will make the job easier. Yes. Okay, online, anyone has a doubt? Kindly tell me. Everyone, please confirm if you all are clear.
No doubt, sir.
Yes, sir.
Daman, Manas, did you understood about the polar protic nature now?
Yes, sir.
Retention inversion also? Okay. Guys, give the headline SN2. All of you give the headline. Bimolecular, bimolecular nucleophilic substitution. Guys, give the headline. We call it as SN2. Oh, I have written biomolecular. My bad. It's bimolecular. No. Okay, it's fine now. It's not fine. Let it be. It's okay. I'll write it manually. All right, now say this. Why it's called bimolecular, guys? Let's understand this. It is because the rate of reaction ROR is directly proportional not only with the concentration of alkyl halide but also with the concentration of nucleophile. Okay, that's why it's called bimolecular. Is it clear for everyone? It depends on both concentration of alkyl halide and nucleophile. Okay. Now let's see here one thing. So point by point, first of all, remember no carb cation intermediate. So guys, there is no carb cation intermediate. Moreover, when there is no carb cation, it's only a single step reaction. So one step reaction. I hope it's clear. The reaction happens in just one shot, okay? Also write it down. We don't use polar protic solvent, rather we use polar aprotic solvent. It means the breaking of bond will happen, but there will be no capturing. Is it clear? Polar aprotic. Whenever we add a word A before any alpha, any word alphabet A, it means absent. Is it clear? So guys, write it down. Yes. Also, guys, remember, please remember there is one similarity there. Only one similarity is there between Sn1 and Sn2. And what is that? Both are exothermic reaction. They both are exothermic reaction. It means they both are favored at low temperature. All right. Take a note of this. It's super important. Guys, write it down. The rate of reaction is inversely proportional to, understand here, there's no carb cation, don't do 3 to 1. It is inversely proportional to steric hindrance, yes. Guys, steric hindrance means bulky group. Do remember, if there is a bigger alkyl group, it means like a 3-degree alkyl halide will be the slowest. So that is why what will be the order of reaction then? So rate of reaction is actually it's 1 degree the fastest, then 2 degree and then 3 degree. This is the order. 1 degree will be the fastest, okay? Because 1 degree is the simplest alcohol, right? The smaller it is, the faster it will be. So is it not wrong to say methyl alcohol will be the fastest to give SN2 reaction? Okay, ठीक है? Online, is everyone understood about the SN2 introduction?
Yes, sir.
Okay. So now let's write it down one more thing. The examples of polar aprotic solvents. example. So you need to write an example for them. So first is the best one, acetone. Second one is DMSO, dimethyl sulfoxide. Last one DMF, dimethyl formamide. Okay, so write it down. Dimethyl sulfoxide. Guys, dimethyl sulfoxide and dimethyl formamide. Guys, DMF and DMSO with acetone. These all are, they are polar in nature. They break the bond, but remember, they do not capture the removed nucleophile. I hope it is clear. Now you might ask me, sir, why do we need to remember these examples? See, if it is a 1 degree, you can, if it is a Sn1 reaction, you can simply say 3 to 1. If it is Sn2, you'll say 1 to 3. But what if they have given you 2 degree alkyl halide then? 2 degree can go anywhere, right? So when you have a 2 degree alkyl halide, it can either go at Sn1, it can also give Sn2. So how will you decide will it be Sn1 or Sn2? Based on your solvent, whether the example given is the polar protic or the polar aprotic. Write it down. This is very much important for Sn2 2 degree alkyl halides reactions. Okay. Manas, you understood this?
Sir, I have a doubt.
Yep.
Sir, so if it is a um, polar protic solvent,
Uh-huh.
first degree, uh, hal- first degree alkane, then it won't be possible, sir.
No, 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 no. 1 degree, first of all, you will not, guys, understand. First, you will see the degree. Based on that, you decide. Solvent will be deciding only when there is a 2 degree. Then you will look at the solvent. Okay, solvent you don't have to look at until it's a 1 degree or 3 degree. Only for 2 degree we check the solvent and then we
Oh,
decide.
okay, sir.
Okay, is it clear for everyone? Then also, see, first of all, understand. Have you heard of a Lucas test which decides, which helps in the distinction between 1 degree, 2 degree, 3 degree alcohol and hydrous ZnCl2 and HCl, right? So basically, it also based on stability of carcatan, and that is why 3 degree alcohol gives the test immediately white color turbidity, right? 2 degree gives after some time, 5-10 minutes. 3 degree, 1 degree never gives. Yeah, so that is why Anusha understand even in the solvent again. First, we'll see the degree what is there. Okay, all right. Is it clear for everyone? Online, kindly confirm. Are you all clear?
Yes.
Yes, sir.
Okay. So guys, now it's time for mechanism. My dear students, write down. We have mechanism. So guys, can we do the mechanism now? Can everyone be quiet? Now tell me in the mechanism, it has only one step. And what is the order of reaction here? Steric hindrance is there, so 1, 2, 3. So which alcohol we take ideally? Methyl alcohol, right? So let's take the example of a methyl alcohol. Guys, let's take the example of methyl alcohol. And what do we add here? Guys, obviously we will add the acetone in the presence of acetone. But how? What will be the nucleophile? Acetone तो ठीक है. We can take some strong nucleophile like KOH. Now tell me what will be the nucleophile will come up from this? You can take no. It's not alcohol, it's a base, alkali. KOH it is. Aqueous KOH. You can take it. No, no, no. You have to take aqueous KOH. Remember this. Very good, Sanita. Alcoholic forms elimination, dehydrohalogenation. Aqueous will be nucleophilic substitute. So what this KOH will give? Which nucleophile? Again OH minus. Huh?
That'll be the same thing at the end then. Because you're taking alcohol.
Oh, my bad. Here I have taken a wrong alcohol. We should take methyl halide. No, guys, got it now. It's fine. My bad. Yes. Is it clear? So, guys, we are not taking methyl alcohol. We are taking a, methyl halide, methyl iodide, right? Understood, everyone? Now tell me, because it is a polar aprotic solvent. Now understand, this is very important. Here I'll make some small changes, guys, with the bond of the hydrogen, two bonds. So what I'll do is, one I'll take in the dash form and one I'll represent in the wedge. Okay. Why I'm taking wedge and dash, guys? See, wedge means towards you, dash away from you, One is outside this board, one is inside this board. Is it clear, no? Yeah. So guys, understand here why we are doing it so. It's just a way of taking a representation, okay? To represent the position of retention inversion. I hope it's clear. And I forgot to tell you one very, very important thing. Guys, one point you need to add here before we go. I forgot to add, remember in SN2 only inversion is formed. Only inversion, no retention. Only inversion, no retention. Guys, I forgot to tell you in SN2, remember, I'll tell you the reason why. All of you write this note. In SN2, remember, only inversion is formed, retention is not there. Now you will ask me a question that, sir, this is also, when iodine will be removed, it is also sp2. Then why it can't have attack from both sides? Remember, in SN1, you were capturing the nucleophile. In this case, you are not capturing. So what is happening, understand, still there is a nucleophile. So what will happen? It won't allow the attack from the front. In SN2, what happens? The breakup and the new bond formation happens at the same time, simultaneously. So when it is detaching, then only the new bond is forming. So that is why it never allows the attack from the front. Is it clear? It will repel. Nucleophile will repel, right? So that is why we only get inversion, no retention is formed. Is it clear? Online, is it clear for everyone?
Yes, sir.
Which is dash and which is right.
This is dash, this is wedge. Okay. See, dash, 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 dash. And wedge. I mean, you order on the Pizza Hut, right?
I thought the other one was veg because that's how it looks like veg fries. Veg fries.
It's not veg, it's a wedge.
I know. Like, so it's like
W, wedge.
but like last time I
Are
ordered.
they consider anything? It doesn't matter. It's just there. Okay. Guys, wedge and dash will matter when I'll cover the competitive part. Right now, here it doesn't matter. So chill. Now, please pay attention here. Okay. So yes. So let's write. Let's write. See what will happen, guys. So see, this bond is breaking, right? CX bond is breaking, and this new bond, because I said only inversion, this new bond is forming, and the hydrogen bonds will remain as it is. So this forms a intermediate stage, guys, where you can see it looks like the carbon has 5 bonds, which is not possible. It is not 5 bond. We are just trying to show 2 events at one time. You're getting it, no? So it is a intermediate stage, very short-lived. It's a very short-lived intermediate stage, okay?
So just try to show that I is leaving.
Yes. So, so why this is a dotted line is there? Because two things are happening at the same time, detaching and attaching. Exactly. So finally you get a product here, and that will be a methyl alcohol. I hope it is clear. Guys, done. Mechanism is over, okay? All of you, please draw this. Guys, if you want, you can also write it. It lives only for 10 to the power minus 6 seconds. That is how it lives for. Okay, 10 to the power microseconds. Okay, got it, John? Online is everyone clear? Crystal clear? Kindly confirm.
Yes, sir.
Okay. Guys, remember the strong nucleophile signifies Sn2, weak nucleophile signifies Sn1. Because we don't need a strong nucleophile in Sn1 because there is water is doing all the job, right? Capturing. It has a capturing polar protic solvent. Here it is not a capturing one, right? So remember only inversion is possible, no retention. Hope you all have understood why retention is not possible here despite the intermediate carbon being like, sp2, right? It's because the attachment and detachment happens at the same time. So that old nucleophile will not allow the attack from the front because nucleophile will have a strong repulsion. Is it clear? Okay. So now we'll do some questions. Okay.
So why can't you use polyprotic solvent for SN?
Why can't we use for SN2? Because it's not required. You have a strong nucleophile here, right? You're getting my point. It's not required. And if you by chance do it, they itself give their nucleophile and that will cause the SN1 to happen, right? But it's not like you can't use it, you may use it, okay? It's still the answer won't change here, right? Is it clear? So guys, let's do one question now. Tell me now, guys, so write down questions. Huh. Yeah, what is that? Tell me.
Veg. Oh, wait.
Okay, now you have a chlorine here, and here I am adding KCN with DMF. And here I am adding, guys, H2O. Now write both the answers. All of you write down both the answers now. Yeah, these are something old, but I'm giving it for practice. New ones will come now. Guys, solve it now. Yeah, Anirudh, can you tell me the answer? Hanvi? First of all, check what degree is there if the chlorine is removed. At what carbon the chlorine is there? Which degree is this?
Sir,
Yep.
sir, can you redraw the question, sir?
You are not able to see the question.
No, sir. It's little bit harder to understand.
See, there is nothing. This is a wedge I have drawn, right? It's a wedge. Can you see that?
Yes, sir. That I understood.
Yeah. Is it fine now? Can you see it with clearly now? Yes.
Sir, but it only has three bonds, right, sir?
How it has three bonds? The other one is a hydrogen. If there is no bond is not shown, it means it's a hydrogen, right?
Okay, sir. Understood.
Yes, it's correct. You have written the mechanism also. You should show in the same context of wedge and dash, right? You got it right. How the question is asked. So, guys, see the answer. Hey, tell me what is the nucleophile will come up from here, everyone. See, first of all, see this carbon is in 2 degree, right? And I have told you 2 degree can go anywhere. So how do we decide 2 degree? It depends on the solvent and nucleophile, right? Solvent mainly. So DMF is a solvent for Sn2. So here it will be Sn2 reaction. H2O will cause Sn1. Polar aprotic and polar protic, right? H2O, what nucleophile will generate? OH minus. What will be the nucleophile here? Cn minus. Now we know here it is only inversion, and here it is inversion plus retention both. So only inversion means wedge ko you make it a dash. Paranit, you understood now? So in the dash you put the new nucleophile, that is Cn. I hope it is clear. And in this case, in place of Cl, you will put OH. So it is when you put so it was a wedge, and when it remains a wedge, it's a retention. And you put OH plus, and the other one you make it a dash with OH. So this is your retention and inversion, and the Sn2 only inversion. Online, is everyone clear? Understood the idea about it?
Yes, sir.
Okay. So guys, one more thing I need to tell you. Uh, should I continue? Is everyone done? Written everything?
1 minute, sir.
Okay. So Daman, you got the idea now?
It's
How much time do we have? Yeah, we'll do some more questions.
Yes, we're done.
Okay. So one more thing I have to tell you here. Guys, let's go back to SN1 when I told you about racemic mixture. I have to tell you something here. So now, so dear students, now understand. If the inversion and retention are formed, and if they are mirror image of each other, leave that optically active. So what I'm trying to tell, when they both are mirror image, like in this case, is it a mirror image or not? Yes. It is a mirror image, right? How do we know it is a mirror image or not? For mirror image, it should be non-superimposable. It should be non-superimposable, right? It means you pick this up and put it there. If it overlaps 100%, it's superimposable. Then it is not a mirror image. Online, should I repeat again if you want to write it? Remember, when it is not superimposable, then only it will be a mirror image. Like in this case, right? When we pick this up and I put it there, it will not overlap 100%. So then such pairs are called, what do we call? Enantiomers. Write it down. We call them, such pairs are which isomers? Enantiomers. We call them enantiomers. Remember the condition, it shouldn't be a mirror image. It should be a mirror image. Should be you know, non-superimposable, right? But if you look at this online, if you look at these two bottles, can you all see this? Now, if I keep this on it, it overlaps it 100%. Right? This is a superimposable image. This can't be a enantiomer. Online, everyone understood this?
Yes, sir.
So understand, when it is a mirror image, then you call them diastereomers. What do we call them? So I'll write it here. If it is a if it is a mirror image, then we call it as diastereo. Is it clear? Diastereoisomer, okay? I hope it's clear. That's what the difference is, that they are mirror image and it is, oh, my bad, not a mirror image. I missed the word not. Guys, got it now? Take a note of it. Now let's do some fresh questions. One I gave just for the practice. Now, hey, what is that khushbus going on? Okay. So guys, now let's do question now. So this was the question number one. Now question number two. Guys, the question is asking one bromobutane. Hey, I can write it a bit proper way. And 2-bromobutane. So guys, the question is asking, hey, what is the joke going on? The question is asking which will undergo faster SN2 and why? So guys, N-bromobutane versus 2-bromobutane, who will give the fastest SN2? Yes, the answer is very, very clear. It will be N-bromobutane because steric hindrance is less. But remember, in exam, you can't directly say it. You need to draw the structure and you need to indicate. That's how you should do, okay? No, you still should be on the safer side, okay? Don't take the chances. Because board exam is all about elaborating the answers, not like MCQ, okay? You're not writing entrance. Clear with everyone? First question is very easy. Okay. Guys, question number three now. Allyl chloride is more reactive. Allyl chloride is more reactive than N-propyl chloride. N-propyl. N-propyl chloride towards N-propyl. SN reaction. Explain. N means the straight chain, simple. Array propyl means, it's a common name. It's not a IUPAC name. So when we say N means it's a straight chain, three carbons in straight. Guys, got it now? All of you, please solve this. And yeah, I forgot to mention SN1. Yes. Guys, explain that now. So first thing you should do, you should draw the structure. All of you draw the structure now. All of you draw it. So guys, understand. Online, anyone wants to give the answer for this? See, SN1 means, what do you mean by SN1? It stability of carpetine, yes or no? Stability of Carb-cation, my dear students, stability of carb-cation, right? Now, if we see allyl chloride and when we see N-propyl chloride, right? What do you mean by propyl C3H7Cl? Can you all construct the structure for this? Huh? Yeah. So all of you see here, understand everyone here. So you draw the three carbons and where should I put the Cl? Because it says N, you can either put here or here, whatever. And rest all are, yes, CH3, CH2, and this one also should be CH, right? Oh my God, yes. Yes. So guys, understand. So what is the degree of this? Now let's draw the allyl chloride. What do you mean by allyl chloride? The carbon which has a halogen is connected with a such carbon which is involved in double bond. Guys, got it? No? So maybe we can picture that something like this. The carbon which has a halogen is connected with a double bond. 1, 2, 3, so CH. That you have to take a rough idea because it's any allyl will be like this, right? That's what I'm coming to the point. Let me write why I'm not able to write H here. It's fine. And how many H will be here? 2. My dear students, please say this. Hey, all of you see here. This is your N-propyl chloride. This is your allyl chloride. I am sure everyone knows about allyl. What does allyl means? Online? Do you all know what allyl means? Hello?
Yes,
Yes,
sir.
sir.
Allyl means the carbon which has a halogen is connected with such carbon which is involved in double bond. Got it, no? Huh. So now understand both of these three. So 1 degree, this is 1 degree. Sn1 means stability of carpetan, right? This is also 1 degree. Now we are in trouble. 1 degree is very bad. What hyperconjugation? You can't just randomly insert hyperconjugation like Dhruv is putting up hysteric hindrance anywhere, right? Yes, the right answer is there is a resonance, guys. Let me tell you, when you break this bond, understand, guys, when you break this bond, the plus charge will come here, and you see, I'm doing it at a wrong place. So when you break this bond, the plus charge will come here. And remember for resonance, what I have told you, pi sigma plus. If you see this sequence, pi sigma plus. If you see this sequence, it means resonance will happen, right? I hope it is clear. I think few days before I've shared a video also on resonance. Okay, if you watch it, it will be helpful for you. So guys, understand pi sigma plus. So it is a resonance stabilized, guys. Can you all see that? Yes. Can?
You said in the beginning.
No carb cation shifting will happen here, right? Because it's already resonance stabilized. Left one
Yes, sir.
carb cation, what are you saying? That if you put a if you put a bond, now for that also I have answer. You do carb cation, rearrangement will happen here. So when the shifting will happen, it will become 2 degree. But let me tell you, 1 degree resonance stabilized is more stable than a normal 2 degree. Okay, so even when you do, rearrangement, it's still with this will be more stable. I hope it's clear. So, Aditi, you're asking something?
So between allylic and benzylic, which is more stable?
Allylic versus benzylic, any day, benzylic is the supreme most stable, okay? Because it has more resonating structures. Is it clear? So guys,
Yes, sir.
understand here, first of all, so because it is resonance stabilized, so it's not 1 degree normal, it's 1 degree resonance stabilized. Okay, that is why this will be faster. So guys, remember this order of carcatan that 1 degree carcatan is the least stable. Then comes a normal 2 degree carcatan. Then you have 1 degree resonance stabilized, and first is allylic, and then comes benzylic. Okay, 1 degree resonance stabilized benzylic. Guys, remember this order. Okay. Yes. No. Oh, we have written 2 degree, right? Then you have normal 3 degree. Then your order will be then 2 degree resonance stabilized, again allylic. Then what it will be? 2 degree resonance stabilized, benzylic. And finally, who will be the supreme most stable? That is 3 degree resonance stabilized. Same pattern. First allylic, then benzylic. Okay. So this is your order. Online, is everyone clear? Kindly confirm once.
Yes, sir.
Okay. So what is the time now? Last question of the day. Okay. Guys, last question of the day. Okay. So guys, let's do the last question now. Let me draw the structure first. CH2Cl, and you have Cl. Hey, wait. I think I have. Guys, now please understand the question is which will give faster SN2. Who in the first or second? Say this is a different guys. This is a different question. Let's say question number A. This is a question number B. Now tell me which pair will give faster if you compare these two. First or second, and why? Online, I need the answer. Online, I need the guys. This question has came in 2009 and 2012 and 2014. 3 years it has come in the board exam. Wait. Mohit, Arav, Daman, Aditi, anyone? Danvi, Vishal, Anirudh, what is the answer, guys, for the first one? A question.
So one, right?
One, why? Aditi, why it is one? Why it is one? Guys, understand here. SN2 means steric hindrance, the smaller degree, right? The faster. Guys, please see here. This carbon is a 2 degree, but this carbon is 1 degree. So the first one is the answer. And in this question, guys, what is the answer? Iodine or chlorine one?
Iodine.
Iodine is a better living group. So here also this is the answer. So these are just the warm-up questions, guys. We will do more on this topic when we begin tomorrow in the organic chemistry class.
Sir, can you please explain the A part once again?
A part, understand Sn2 means Sn2 means the steric hindrance, right? The order is 1 degree is the fastest, 2 degrees and 3 degrees the least, right? Here
Yes.
the carbon which has a halogen is 2 degree, here it has 1 degree. That's why this is the answer, okay? Simple.
Okay. Got it.
All right. So bye everyone. We'll meet tomorrow in the evening. And tomorrow 2 o'clock is doubtful. Just for tomorrow, I'll confirm in the message, okay? Bye, 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 bye everyone.
How class with
Thank you, sir.
Thank you, sir.
Thank you, sir.
5:45.